looks like my colleague is not going to be here to make an announcement. Maybe they will be here next week, but since they're not here now, we're going to move on, and we're going to cover spreadsheet exercise number 2. So spreadsheet exercise number 2. The basic premise of spreadsheet exercise number 2 is that you've been given a report. Okay, you've been given a report and you've been asked to basically analyze the data in the report, or provide graphs and figures. The whole point of this exercise is to get you comfortable working with figures. So and making graphs and charts and things like that. So you're given this report, and this introduction section kind of walks you through the assignment and how you might go about analyzing these things and depicting them visually. So one of the first key pieces of information that you're given is that we're talking about nitrogen. We're talking about nitrogen pollution specifically, and that there's this watershed that has a whole lot of nitrogen being discharged into it. So what you're going to need to do is convert these figures, this total tons of nitrogen per year, into, you've got your percentages here. And so you're going to need to multiply the percentage by the total to get the mass of each category here. So you have overland discharge, internal cycling, wastewater treatment plant, and atmospheric deposition. Here's the percentages of the total amount of nitrogen pollution that these represent. And at some point, you're just going to need to come up with a mass. Okay, so you're going to be converting percentages to mass. And that's very straightforward because you have the total tons here. You literally just multiply the tons by the percent, and you get the mass of each of these categories. The next piece is a little bit more complicated because what you have here is a percent of a percent in table 2. So of this overland discharge, which is 57.4% of this 367,000 tons per year, you have rangeland and residential with sewer, commercial, residential without sewer. All these categories are smaller percentages of this 57%. So what is 28% of 57% of 367,000 tons per year? And so you're basically just going to be multiplying a percent by a mass, and that's going to give you a mass. And that's going to be how you approach those calculations. Now, the calculations are sort of the easy part. That's on purpose because the point of this exercise is to get you in a place where you have the ability to make charts, right? To make graphs and things like that. So you're going to be making a couple kinds of charts, okay? You're going to be generating bar charts and pie charts, okay? And the big thing to understand here is that bar charts are very good at conveying information about the actual value that you're putting in the graph. So if it's 50,000 tons, the bar chart will show you that there's 50,000 tons. Pie charts are instead really useful for percentages, for relative contributions, proportions, things like that. So you lose the information unless you put it in a label about how much the raw value was, whether it was 50,000, 500,000, you don't really know. You just know that it's 20% or about 20% of the total amount that we're talking about. So pie charts, again, are useful for showing relative amounts or relative contributions. Bar charts are useful for showing the total amount. And as well, you can also have them show relative contributions. But if you really want to convey relative information about what fraction X category is of a total, pie charts are the way to go for that. So I think that about covers it as far as what we're going to do. So you see in your document that you've got these data here. Okay. And so all I'm going to do is just select this table, copy the table, and I'm going to paste it right here. Now it looks a little funky. Okay. It pasted over all the formatting, and I want to just have the destination formatting. I just want it to look really straightforward. Okay. But this isn't quite good enough. It's just kind of sitting there up at the top. And I know that there's more information that I want to have in this spreadsheet. And so what I'm doing here is I'm inserting blank rows above this information right here. And the first thing that I'm going to put up way up at the top is the total amount of nitrogen pollution that is in this watershed. Okay. And I'm going to change the width of this column by clicking and dragging, left click and drag. Then I can change the width of the column so that I don't have this overlap here. Because if I enter information into column B, 367210, it overwrites that information here in column A. I can't see it anymore. And so I want to move this over so that I've got the ability to see that entire column. And in fact, looking down below, I can see that I'm going to want to have this information, this column moved all the way out here. The other thing I might want to do, though, rather than do that, is just delete all that and shorten it. Shorten wastewater treatment plant to WWTP so that I can make this column a little bit more reasonable in size. Okay. So just to make it match the key so you don't get confused when I post the key. Here is what you're looking at for table 1. Okay, we're going to call this table 1, and this is major sources of nitrogen. All right. And so now this is really cleanly set up. We have our nitrogen load up here, and we're going to be able to refer to that cell whenever we want. And then we have the percentages here of the nitrogen load. One of the things you might want to do, just to make sure that this is formatted the way you want, is to go here, select these percentages, select these numbers, and go to format cells. You can just do Control-1 if you're on a Mac. Command, I believe Command-1 works as well. And right now it's just in this general category. You want this to be a number. Okay, and let's make sure that we have 1 decimal place. I could have more decimal places, but the data aren't that far out. We just have 1 decimal place. And if you wanted, you can also do the number, the comma separator for the thousands place, but we don't need that because these are percentages and none of them are going to get that big. The reason that I don't call this a percentage is exactly what you can see here where it says sample. If I say, yeah, this is a percentage, it goes, oh, okay, you put 57.4 in the cell, but it's a percentage. And so what that means is that I multiply 57.4 by 100 to show the percentage. Okay, that's not what we want. All right, we want it to show 57.4. We want to be able to manipulate the number as 57.4. In fact, often what I do is this, and this is not in the key, but I will often do something like this, where instead of representing it as a percentage, I will represent it as a proportion. And what this allows me to do is when I want to go multiply something by a percent, I can just use this proportion figure because, you know, what's 57% of this 3,067 number? Well, if I just do that 300,000 times this, it doesn't know that 300,000 figure is being multiplied by a percentage. It thinks it's multiplying 367,000 by 57.4. And so that produces a very large number, like 21 million. And so rather than do that, what I can do is say, all right, don't multiply by 57.4, multiply by 0.574. And that's going to give me that's going to actually give me the answer I want. Okay. So oftentimes I will say something like, you know, just for me, just for my own mental clarity, I will sometimes put this other column here to make it more clear to myself when I'm keeping track of the data and what I'm multiplying by, that I'm actually intending to multiply by a proportion or by a ratio, not by 57. Okay. So this is a useful trick that you can follow. Another thing you can do is you can, of course, multiply 367,000 by this 57 number, and then you can divide by 100. Okay, because that's going to account, that dividing by 100 is going to account for the fact that really what you want to do is get the proportion. You want to get the percent. You want to get the fraction of this 367,000 figure. And a percentage here, 57.4, to reflect it as a proportion, you just divide by 100. Okay. So in fact, that's what percent means. It's the cent is the root of century. It means 100. And so percent is the fraction of 100. Okay. Or the fraction represented as it would be of 100. So 57% is just 57 over 100. Okay. So next thing that you're going to want to do is enter in the overland discharge, okay, from the report. I'm going to delete this just to keep it simple. And the overland discharge is given in the report that you were handed. Okay, so it's here, right? Percent of overland discharge. Okay. And so what we do is we copy it down, and we're setting up the data right now. That's all we're doing is setting up the data. Okay. Nothing fancy. All right. And in the assignment, one of the next things that it wants you to do after you've gotten to this place, so we've got our data entry, that's good. Okay. Next thing that it wants you to do is include a table 3. And what table 3 is going to do is disaggregate these percentages, specifically this overland discharge percentage, right? Because it's 57%. Okay. But of that 57%, we have these smaller divisions. You know, we have rangeland, we have forest, etc. And so if we wanted to show the overall contributions of every source that we're aware of, we would want to go in and we would want to multiply these percentages by each other. Okay. And so we're going to set this up as table 3, overall percentages disaggregated. Okay. And then we're going to have the same thing that we have here. We're going to have nitrogen. We're going to have overall. Okay. Just copying and pasting. And then we're going to have set up at the top, we're going to have all of our big like source categories. We're going to have internal cycling, wastewater treatment plants, and atmospheric deposition. And then we're going to have these categories of overland discharge. And so we can copy them down here. And then to figure out the percentage, all we're going to do is we're going to say multiply this rangeland figure, 28%, of course, divide it by 100, okay, because this is just a ratio. Multiply that by this, this 57 here, okay? But of course, we want this to be the same the whole way down. Okay, we want every one of these blue cells, every time we move down to residential, commercial, etc., we want it to refer to this exact same cell, B6. Okay. And so when we do that, and we can just double click here, when we do that, we get these percentages. Okay. Now I'm going to format these cells to just have one decimal place. All right. And then I'm going to make sure that it all adds up to 100. And it does. Look at that. Very cool. Okay. So now we have a situation, and save your work. Here, I'll save my work. Always save your work. Save early and often. So now we've got our overall percentages. We know the overall fraction for each of these categories that we have the overall fraction of the 367,000 for each of these categories. Okay. The next thing that you need to do is calculate the mass from all of these disaggregated sources. Okay. And this leads us to table 4 and 5 shown in figure 3. So this is what we're aiming for. This is what things are going to look like. Okay. And so the way that we're going to do this is pretty straightforward. All right. We're going to do the same thing we've been doing before. Table 4, this is going to be called overall disaggregated load. That is a terrible misspelling. And it's going to be in tons per year. So always make sure that your units are listed at the top. Okay. You want, whenever you're making a data table, you want your units to be very, very clear. And I always err on the side of having the units be listed too many times than not enough times. Okay. So here we've got a situation where we want to know the total load of internal cycling. So what do? Well, pretty straightforward. We take this percentage, divide by 100, just because, again, we need to remember that it's a percentage. We want a fraction. So what we have then here is 37.7 divided by 100, which is 0.377. And then we're going to multiply that by cell B1. Okay. We want to multiply it by the total load across the watershed, 367,000. And we want to make each of these cells, as we move down, multiply by the exact same total load. And so we say refer only to this cell, and we put the $sign in front of the B and the $sign in front of the 1. So it will only refer to that cell from that point forward. We double click, or we left click and drag, same effect. We can also just copy and paste and paste and paste and paste and paste, because remember what Excel is doing is copying and pasting the total, the formula. It's copying and pasting what's up here, this expression. It's not copying and pasting the value. By default, you can make it paste the value, but we're not doing that right now. We're going to format this. Because these numbers get pretty big, we're going to add the comma separator so that it's easy to see. And also, because these numbers are pretty big, we're going to get rid of the decimal points. Okay. And, you know, your chemistry or physical science instructor in 9th grade would throw a fit about significant figures here. But I have not encountered that in my day job. I get paid as a professional scientist. So I'm not going to throw a fit about significant figures right now. So what does that mean for overall load in terms of tons per year if we aggregate these categories? Again, this is just making sure that we've got our bases covered. If we want to make charts of any of this, we want to make sure we've got these data tables set up so that we can use them to make charts. Okay, so we're doing the data prep first. And so if we're doing the aggregated total, okay, then we're going to go here. We're going to go to overland discharge, internal cycling, wastewater treatment plants, atmospheric deposition. We're going to have a total row. Okay. And we're going to not forget our headers. We're going to say nitrogen sources. So we need a header for the column. Okay, nitrogen source. We don't want to just have the data start. We want to make sure that the user of the data is able to see what is below it, like the category of things that are below these headers. Okay. And we're going to do load in tons per year. And so again, the same sort of thing happens here. We just say overland discharge. What is that? That is this 57%. Again, divide by 100. And then multiply all that by cell B1. Okay. We're making this look nice and pretty. And then for total, we're going to sum all these columns, okay? So this is interesting. This one, we got the right answer for the wrong reason, because this total was referring to this cell, which is 100%, because it sums all these other percentages. Really, what should happen here is, rather than have it refer to that cell, you should make this sum all of these values, so that if these values change, it refers to this table. You want to try to have your tables refer internally to themselves, and data within the table, when you're summarizing as a total or something like that, you want to avoid having it go outside the table if you can. So now we've got all of our tables set up, and the next task here is to make graphs. Okay, and so I'm going to name this sheet nitrogen data, and I'm going to name this next sheet table 1, because we're making a graph of table 1. We're also going to be making a graph of table 2, table 3, table 4, etc. So we're just going to make tabs of your spreadsheet, label them as tables 1 through 5. And then we're just going to copy the values straight over. Now, I could copy the, I could make these tables refer to specific cells so that they update automatically. So what do I mean by that? What I mean is, I can copy this table, the whole table 1, okay, paste it in. All right. And I've got here, let me make this not tiny. Okay. So now I've got table 1, and these values are pasted in, but I could say, hey, make this cell equal to, go and click over onto that cell. And now this is cell, it's saying here, make this cell equal to nitrogen data, that sheet, cell B6. Okay. And in fact, I could swoop that down, and it's going to say, oh, refer to cell B7, B8, B9, etc. And I can go over here and say, you know what, there's a typo in the report, and this is actually 58.2. All right. And what do you know? This updates to 58.2. Okay. So you can make these tables refer to, that we're going to, build our graphs off of. You can make them refer to your original data. All right. In this sheet. So let's do the same thing here for table 2. Okay, we're going to copy table 2, paste table 2, make sure that this is big enough for everybody to see. All right. And I'm just going to do the same thing, because this is generally good practice. Okay, to make your data that you're building your charts off of automatically update to your sort of master data sheet. Okay. And the reason for that is because, again, anytime you might need to make a correction or change your master data sheet, you want it to update your charts automatically. Okay. So let me complete this exercise. We're going to go and we're going to paste in table 2. We've pasted in table 2. Now we're doing table 3. All right. And you'll note that here it's saying, hey, I don't know what to refer to. There's this weird reference here. Like I've lost my reference. And the reason for that is because it is trying to find whatever cell was here, but it doesn't exist in this sheet anymore. Okay. And so one way around that is to copy and then paste special and just do values. So now, instead of the formula, instead of the expression, what you've got is just the number. Okay. Only the number is there and available. And so this will not update automatically. So if you want it to update automatically, you press equals, you click over to nitrogen data, and you click on the cell that you want it to represent. Okay. And then, of course, we need to format. And here we go. All right, so we're just going to do that for the rest of these. Copy, paste, and look at that. It says, hey, I don't know where to look. And you say, don't worry. I want you to look over here. Here. Lost it. There you go. Double click, and voila, they all update. Okay. So we're going to do that again. Okay. So now we're in a situation where we can start making our graphs. Okay. So what are the graphs that we want to make? Well, let's see. The assignment basically says, once you've got all of your data, we're going to make some pie charts. Okay. First thing we're going to make is pie charts because they're the most straightforward. It's a proportion. Everybody has an intuitive understanding of what they are. Okay. And it looks like we're going to be making a something for table 6 here, but we're going to ignore that for now. So for table 1, we want a pie chart. We want a basic pie chart. And so what we're going to do to make a basic pie chart is we are going to select these data. Okay, include nitrogen source, because we want the header. That's going to be an important label in our chart. Okay. Same with overall percentage. We're going to want that to be part of the label for our chart. And we're just going to go over to this insert tab. All right. And we're going to click on, there's a number. You can click on recommended charts. You can click on the pie. Okay. I find that the recommended charts are sometimes the most straightforward. Okay. It's going to show us some options. Do we want bar charts? Well, no, we don't want bar charts because these are percentages. And as a general matter, percentages should be reflected in pie charts. And so we're going to go over here and we're going to set up a pie chart. Okay. And what you can see here is it's looking at this label and it's saying overall percentage. Okay, I'm going to make that the title. So it's automatically making the header of the data column the title of the chart. And then you can see down below the colors are labeled by these row labels, and each of these pie slices or fractions of the pie reflects the values that are depicted here in column B. So right now this is okay. We've got a pie chart. Okay. But we want to customize it. We want this thing to look good. We don't want it to just sort of sit here. Like, what if someone wants to know the actual percentage? What if someone wants to know what that value is? Okay. So what also happens, if someone says these are too small, there's a number of ways to go about it. You can go, into chart design, and you can go add chart element. Okay. That's the most straightforward. You can go data labels and you can say, well, where do I want the data labels? Well, let's just say I want the data labels, at the best fit, just automatically put it somewhere. I don't like that. It shrinks my chart. Okay. I want my chart to look good. What if I say center? Okay, well, that doesn't look good either because these two numbers are overlapping each other. So you get a sense, right? There's a number of ways to do this. This data call out thing's sort of worse in the same way. It makes our chart smaller. We don't want that. Okay. So maybe you arrive at outside end or something like that. Okay. Maybe that's where you arrive at. But it's right now, it's just the numbers. Okay. Like maybe we don't want that at all. maybe we want more label options. Okay. And so if you go over here, what you're going to find are all kinds of options. Okay. We do want the label to be the value. We do want to show leader lines. Okay. And for a number of things, we're going to want to have these labels here that are down below. We're going to want those to be part of the we're going to want those to be part of the label itself. Okay. And so we're going to add the series name. All right. And so here we've got overall percentage. That's not very useful. Okay. We don't want to have series name. We want to have category name, right? Because that's going to give us much more information. So we're going to go and we're going to try to select. Why is it not letting me select? There we go. We can select everything. We go to label options and we want category name. Perfect. So we have overland discharge, wastewater treatment plants, atmospheric deposition. The color looks a little odd. I don't like gray. I want it to be easily distinguishable. Okay. I don't want a fill. I want the text to be a specific color. I want the text to be black. All right. I'm going to move atmospheric deposition over here, wastewater treatment plant over here. All right. And we're just going to sort of arrange things as we see fit. Okay. Let's change this too. Overall percentage isn't very informative. Overall percentage of what? We want to make sure that people understand it's of the nitrogen load. And now that we've got the labels on the inside, we really don't need them down here, do we? Okay. Now, why is that not showing? The leader line. Well, it's not showing the leader line for some reason. There we go. Now it's showing the leader line. All right. And so these lines help the person viewing get a sense of what the category actually is, where the category is in the chart. Okay. They can they point to it. So here we go. Now we've got our chart. Okay. The text is all black. Okay. We could probably make the text bigger. 9-point font is maybe a little small. So, we could make it 10-point font or 12-point font or something like that. All right. Just so that it's really easy to see from the back of a room if we're giving a presentation. So there it is. That's our first pie chart. The key to getting into the nuts and bolts of what you want the chart to look like is formatting data labels. So again, if I go to chart design, add chart element, data labels, more data label options, it opens this pane here on the right. Okay, this window pane here on the right. And this allows us to customize the data, customize how this looks. Okay, you can also customize the text. All right, you could, for whatever reason, make the text invisible. Okay, you could give the text a shadow of some kind. There's a lot of things you can do to the text here. Okay, I can make the shadow like super intense. I can make the shadow not that intense. All right, etc. So table 2. Okay, we want to do basically the exact same thing. So we select everything, insert, recommended charts, pie chart. I'm going to move down here so we can see the whole thing. Overland percentage of what? We're going to change that to percentage of overland discharge of nitrogen. Okay. Now we have a good sense of what we're actually looking at. We're going to go into add chart element, data labels, more options. We're going to go label options. We're going to say we want the category name, we want the value, we want the leader lines. Yes, yes, this is all good. We're going to delete these labels because we already have them now here. All right. We want this to be black text. We want it to be size 12 font. Okay. We want this to be black text as well. We want there to be a little bit of space. All right. So we press return. And then we're just going to play around with this. You know, we've got forest here. I don't know why it's got that awkward comma. There we go. We need to make the box a little bit bigger. I'm going to put it outside. And then we're going to actually, I really don't want forest to look like that. Actually, it's vineyards. I don't want to look like that. There we go. Just make it bigger. So what I'm doing here is trying to make all the boxes consistent, all the label boxes consistent, so that the 3 is below the category value. Okay, we want the rangeland 28, residential with sewer 25, etc. We just want these to all look the same. Now you might disagree. You might say, hey, actually what I want is for these things to all be right next to each other. I don't want this like down here. I want it up here. I want it all in line, and that's fine. When you look at the key, you'll see that the key has it set up that way. Everything is all in line. The idea is that you just want it to be consistent. Okay, you want it to be as consistent as possible. And sometimes to do that, you have to make the text box a different size. You have to make the text box bigger or smaller. Up to you. So we'll make our leader lines the same color. We'll make them black. Go over here to the paint bucket because that tells us what we want our colors to be. Okay. And so there we go. It's not perfect, but it's good enough for right now, just so you get the idea. Okay. And so what this shows you is the percentage of the nitrogen load that is coming from overland discharge of each of these categories. So rangeland is 28% of the overland discharge. Okay, great. That's awesome. Perfect. All right. And for table 3, we're going to do something that looks, again, basically exactly the same. We're going to go, and because again, we're dealing in percentages, we're going to insert a recommended chart. Let's just get rid of that right away. We're going to make this the size of the whole screen. We're going to retitle the chart as percentage of nitrogen load. We are going to format our data labels. Okay. We're going to make sure that we have our series name. We're going to make sure that these are all solid, whoops, that they, that the text is all black text. We're going to change the text to 12-point font. We are going to make this black text here, make the title black text. Okay. And this isn't perfect. Again, you would have to make this like a really good chart. You'd have to move some things around. But for the most part, we've got a good idea of what our categories are. We have a pretty good idea of where they reside in the chart. They're labeled. We have the values, the percentages associated with them. Oh, and there's our problem. We need to do the category name, not the series name. Okay. And so here it is. Right now we've got our pie chart that shows each category. It shows the percentage that category is as a fraction of the whole. All right. And you can see it depicted visually. Okay, so it's better than a table in a lot of ways, because this table here, although the information are certainly there, it's presented. Okay, it's there. Sometimes people like pictures. People like visuals. They like to be able to just look at this and say, internal cycling, rangeland, and residential with sewer. Those are our big categories. Those are the ones that we really need to look out for. And I can see it. Boom, it's right there. It just pops. Now, what if instead of it looking like this, with these two tiny slivers here hanging out in this awkward order, big slivers, little slivers, more big slivers, what if I just said, you know what? Forget this. I want to sort this. I want this to all go from biggest to smallest. How do I do that? I go to data, I select it, I go to data, I go sort. I pick a column, overall percentage, largest to smallest, boom. It sorts it, and then the chart changes to reflect that sorting. And then I just need to make sure that I'm moving my boys around here. And you would fiddle with this and get the leader lines to show up as appropriate. Okay. There. And so now we've got a nice, pretty looking chart from largest descending to smallest. We have the numbers, the figures represented here. We have the categories. All right. If you were really a stickler, you could get in here and start changing the colors to reflect some other kind of information, but we don't really want to do that. So here's what we're going to do with this. There's a problem here, and it's that we've got all these little guys here that really, like, they're kind of cluttering the chart, right? You know, everything under wastewater treatment plants is kind of just in the way. All right. Pasture, other land uses, atmospheric deposition, we can kind of ignore that. You know, like, I mean, I don't want to say ignore, but it's really not something that we have to pay really close attention to. So one of the things that we can do is make a chart that refers to an other category. So other, in this instance, okay, is going to be equal to this column, sorry, this cell plus this cell plus this cell. Okay, 5.78. So we're going to go here, we're going to create other. It's not going to be other land uses. No, no, no. And it's going to be 5.7%. We are going to delete those rows. This is still going to sum to 100, just to make this look pretty, just to be consistent. I'm going to reformat it. Then we're going to do the same thing. Going to make a pie chart. And doesn't want to do it that way. being weird. I'm just going to make a pie chart. Okay. And rather than go through making this chart again, what I want to highlight is that now you have this slice right here, this gray slice that is just other. Okay. As opposed to up here where you've got these tiny slices that are all very busy. Okay. And difficult to read and see. And so you've got this other category. And even though other is bigger than wastewater treatment plants or even forests, in fact, I think it's even bigger than orchards and vineyards. Yeah, 5.7. It's the same size as residential without sewer. We leave it at the very end. And this is just by convention that we leave other as the last category, because what's understood is that within that other category, there are a bunch of smaller categories. And so we don't want other to just sort of appear as like a major source. You know, you don't want other to look bigger than residential with sewer. You don't want that to be highlighted as like the fourth largest slice, because really other is just this kind of catch-all group. Okay. So you leave it as the last pie slice on the chart. And the way Excel works, that means that it has to be built in as the last category here. So now let's look at bar charts. So bar charts are built almost exactly the same way. We select the data, we go to insert, recommended charts, and look at that. I prefer vertical bar charts, not horizontal. This is just a preference of mine. And so now we've got a bar chart, and it's like kind of already done. Okay. It could certainly be a lot better. All right. So we're going to give it a better title. We're going to use some labels that show the height of each bar, because right now it's just sort of like, oh, it's about 68,000, but we don't really know what the actual value is. And we'd like to be able to see the actual value, because that's one of the major benefits of a bar chart, is that you can actually depict the actual value. Okay. So here's what we're going to do. We're going to go annual nitrogen load in tons per year. We're going to give it a better title. We're going to go in here and we're going to go to data labels. Give me some more data labels. Aha, there we are. Now we've got our numbers. Okay, label options. What do I want? I want the value. Okay, if I don't have that, then I don't have anything. So I click value here. I don't need a legend key because they're all the same color right now. We're going to change that. But at least now I've got my values. Okay. One of the issues here, though, is that we don't have labels for our axes. Okay. This is important. We need the primary horizontal. Okay. This is going to be load sources. All right. Because it's a graph, we want to have axes. We're going to do the primary vertical. This is going to be nitrogen in tons per year. Okay. And so this is starting to look a lot more like a proper graph, proper chart. Okay. Now, the colors. These are all the same color because they're all nitrogen. Okay, that's good. However, one of the things we know is that these categories here, rangeland, residential with sewer, etc., these are all basically from the same broad category. Okay, and that broad category is overland discharge. Okay, and so we want them to all be depicted as being related to each other. We want them to have a common color. It doesn't make sense to make all of these bars have different colors because they already have their own bar. They don't need to have a bar and a different color. We already know that they're separate, so they don't need their own colors. They already have their own bar. What we do want to do, however, is change the color associated with each of these major categories. So we want wastewater treatment plants to get their own category. And we're going to do this more or less by hand. So we're going to go solid fill. The color is going to be this this orange color. Okay. We're going to click here, and the color is going to be solid fill, and we're just going to make it gray. All right. And then we're going to change each of these one by one. Unfortunately, we can't change it all at once. We have to click on these one by one. Okay. So that's kind of boring. But at the end, now we end up with a chart that depicts, at least visually, that these are all related to each other somehow. And you could even go a step further and add a shape that makes this even more clear. So you can kind of treat this like, you know, anything in like PowerPoint or any kind of you know, editing software or anything like that. And so we can take this bracket and we can insert it here. Okay. And we're going to say, you know, we want this to be a pretty thick line. We want it to be black. And then we can insert a text box. Where's my text box? Text box is over here. Insert a text box and say overland discharge. Okay. And now we've got a chart that is highly illustrative of the situation that we are in. Okay. We've got the numbers associated with each category. We've got the labels, of course. We've got the height of the bar, so it's visually very easy to see that internal cycling is the largest individual contributor. Okay. And then we've got overland discharge here disaggregated, right? We've got it split up. Now, maybe that's not what you want to see. Maybe you want to see what internal discharge, or I'm sorry, overland discharge looks like compared to internal cycling. Okay. And so the most straightforward way to do that is to make a bar chart. Where these are all combined. Okay. And again, I prefer vertical. You can always do horizontal if that's your thing. Okay. We are going to add chart elements. We're going to add a primary horizontal, load sources. We're going to add a primary vertical. This is nitrogen in tons per year. This is the annual nitrogen load in tons per year. And then if we want, we can keep these all the same color. The exercise has them broken out into different colors. That's just because it's pretty, but we don't actually need them to be different colors because it's all nitrogen and we have these categories all set up. What we do want to have, however, are the data labels. So we want data label options. We want the value. It only did one of them. There. So what'll happen is if you're selecting just one of these columns, like, oh, just this one, just overland discharge, it'll give you a data label, but just for overland discharge. When you first click on a given column or a given bar, it'll highlight all the bars. And so then you can go to data labels, more options, Okay. And it's given us the values here. Now, this is a little annoying because the number goes right through a scale bar, but that's easily fixed by moving the number around. Okay. So here it is. This is our bar chart. All right. Again, not very complicated, not very special, but it is what it is. Now, your exercise says that you're going to need to make a table 6 because your supervisor has walked in and said, hey, this is all great, but I want to know how much nitrogen is coming off of each acre of land, and she wants it depicted as a chart. So you know that there's a table somewhere in the report showing the overland load of each source category as well as the acreage of those categories, but the report unfortunately does not include a load per acre. However, this is easy for you to calculate because you now are a spreadsheet master. So what you're going to do, just to make this problem clear, we'll create table 6, nitrogen load per acre. Okay, we have our nitrogen sources. We have our overland load in tons per year. We have our acres. And so this is what you know from the report. This is what is given to you in the report. You already have this. Okay, we can go over to here, copy, paste. We need tons per year. We go over here, we copy, and we paste. Okay, unfortunately, it's referring to other cells, and so we're just going to paste special. We're just going to paste the values here in tons per year. We're going to round that down, add the comma separator. All right, and so now you go to your report and you see, there's this category of acres, and these are the data that you need. Okay, I'm just gonna type them out. Make sure you double check the data every time you go from one source into another. You don't want to have what's called a transcription error. You don't want to transcribe the data improperly. This gets really messy, really hard to trace back. Very common kind of error, but nonetheless one you want to avoid. Okay, and so now what we want to know is how many tons per acre per year are coming off of these categories, and that's pretty straightforward, right? Nitrogen tons per year per acre. Okay, the way that we do that is we say this is how many tons per year are coming off the land. We divide by acres, and voila. This is like really simple stuff. You should be a master at this. We have tons per year. We divide by acreage. We get tons per year per acre. Okay, and so you can see that some categories of land use are very high in terms of the nitrogen tons per acre as compared to others. Forests, pasture land, very low. Okay, even orchards and vineyards are below the average. But the ones that are really high are things like rangeland, residential with sewer, and commercial. And so now you want a bar chart. Okay. Your supervisor wants to not see percentages. She doesn't want to see what's the percentage. I mean, these are values. These are just hard values. And she just wants to see a chart, okay, that shows these things. So what we're going to do to build this chart is we're going to select the data we want. We're here. there. So what I'm doing here is holding down the command key. I don't actually know what it would be on a PC, but I'm able to select 2 columns independently. Okay. And with this, oh, I don't want total. Don't want total, folks, because that's going to screw things up. And in fact, one of the things I want to do here is sort before I make my chart, because I want the highest one to be farthest to the left, unless you had some specific reason that you wanted them to be organized in a different way. But I want them to be organized from largest to smallest here. Okay. And like I said, I want to depict this as a bar chart, like so. Okay. That's too big. So nitrogen tons per year per acre by land cover. Okay. Same thing. Axes, primary, horizontal, load source, or maybe I'll just say land cover. Okay. Or maybe I'll say overland discharge sources. It's even more descriptive, even more useful. Primary vertical, nitrogen in tons per year per acre. Okay. We want there to be data labels. There they are. Values are given. Okay. And again, because this is the same category, this is all nitrogen. All right. We don't actually need to break these out and show them as different colors. The exercise has them as different colors, but you won't be graded down if you keep all of them as the same color. Okay. Because again, these are the same basic constituent. This is all nitrogen. All right. And they all already have their own columns. Now, for those of you who want to get a little more advanced, you can do something called a stacked bar chart. And that would be appropriate for a category like this, or a situation like this, where one of these categories here is actually made up of multiple sources. Okay. So if we were to do that, we would go to insert, bar chart, and we would want a stacked bar chart. So that's one stacked column chart. Looks like this. Okay. And I'm just going to show you how this works as best I can. I'm not going to fiddle around with the rest of it. Just give you a sense of the essence of what a stacked bar chart would do. So what I want is for these different categories I just got in over my head, didn't I? Where is it? We'll go over that next time, because this is not obvious to me right now. So don't worry about a stacked bar chart, and don't worry about a what's called a pie of a pie, which is also something you could do here. So you can click on pie chart and you can get something like this. Yeah, that's straightforward. And you can see that there's this category here, and each of these other categories are broken out. And so what it starts to look like, we delete these labels, data labels, more options, label options, category name. Okay, we want these to be black text. What you can see here is that although it did this automatically, these groupings don't make a lot of sense. It just put the smallest ones all in one place. But what you can see is that if you created a category, for example, that was like overland discharge, you could put internal cycling, wastewater treatment plants, and atmospheric deposition all in the big pie chart. And then in the smaller pie chart over here, you could have pasture, other land uses, forest, orchard, vineyard, etc. And so this is a way of showcasing, what we kind of tried to showcase here, which is all of the data in one place, or even here, which is all the data in one place, but we also have this other category. You can actually break that other category out into its own pie chart. Okay, so that ends up being really useful. And there's ways to fiddle with this, but basically you go in and you say, how many values do you want in the second plot? I could say, all right, I want 5, or I want 6, or I want 3, and it'll give you 3. And then you can go in and say, well, I want to customize which one is in which plot. So I go internal cycling. Yeah, that's in the first plot. Rangeland, that's in the second plot. Okay, residential with sewer, that's in the second plot. All right, wastewater treatment plants, that's in the first plot. And then atmospheric deposition, that's in the first plot. Residential with sewer, second plot. Commercial, second plot, and boom. Okay, now we know, now we've got a big old pie chart here that shows internal cycling, wastewater treatment plants, and atmospheric deposition all as their own slices, because those are all unique categories of nitrogen loading. And then here in this other category, it's all of the overland discharge. It's the residential with sewer, the rangeland, the pasture, etc. And so because those are all like categories, they can get their own pie chart. Okay. And this becomes a really powerful way to illustrate data, especially when you have a subgroup of another group, or categories within a category. And I'm going to figure this out. Not right now, but I'm going to figure out the stacked bar chart. Oh, it wouldn't be this one. It'd be this one. This is the one that I'm looking for. You can imagine it's basically the same thing. It's just that rangeland and residential sewer are stacked on top of each other. Commercial is stacked on top of that, and etc. until they're all one giant bar. Okay. For whatever reason, I'm not seeing how to make that happen right now with this chart. It's a little weird, but I will figure it out, and then I will upload a separate recording showing how this works, just for your information. Okay, that's it. That's today's exercise. That's the spreadsheet exercise 2. Go forth and conquer. The exercise itself is posted. The basic instructions are given, with the guidance and everything, as you can see here. It's kind of got everything in it. It's got the data tables to set up. It shows you where to go to insert a chart, kind of shows you how to set up a chart, what you should get at the end result as your charts, and on and on and on. Okay. So if you have any questions, send me an email, either to my SRJC email or in Canvas. Don't forget to submit your second exam. Don't forget to turn in your reading response for the historical ecology and traditional ecological knowledge. And like I said, I'm going to figure this stacked bar chart out, and I'm going to upload that pretty soon. Okay. Have a good one, everybody.
Thanks, you too.
Indeed. Appreciate you guys showing up. Bonus points for showing up, as always.